So example number 1, a single phase power system consists of 490 volts, 50 Hz generator supplying load, Z load 4 plus J3 ohms through a transmission lines of impedance Z line. So this is the line impedance 0.8 plus J 0.2 for ohms. So answer the following question about this system. A, if the power system is exactly as described in figure 1A, so we see later how the circuit, and what will be the voltage at the load B, and what will the transmission losses be. Okay. And B, suppose a 1 to 10 step up transformer is placed at the generator side. Okay, so this is at the beginning side of the systems of the transmission line, and a 10 to 1 step down transformer is placed at the load end, so the secondary part of the system, or to be particular of the line in figure 1B again. So we will look later how it looks like. So what will the load voltage be now? What will the transmission line losses be now? Okay, so the first one, so let me brief a bit. So we do not have any equipment of transformer. It just straight away a transmission line system with the supply voltage and going through the transmission line before it comes to the load part. Meanwhile, on part number B of question B, so suppose we add in a transformer, two of them with 1 to 10 step up transformer as well as 10 to 1 step down transformer at end part or beginning part of the system. Okay. So figure 1AB here, this is what I mentioned earlier, nothing, no transmission line, no transformer beginning or end part of the transmission line. So sending part and receiving part. But when we come to figure 1B, the power system of example 1, with transformer actually. So without transformer, sorry, so we have a with transformer, 2 unit of them, 1 to 10, and transmission number 2, T2, 10 to 1. Okay, so let us discuss about the answer over here. So this is the solution. Okay, here, all right. So solution number 1 for chapter 2 or example number 1. So figure 1A shows the power system without transformer. Here IG equal to I line equal to I load. All right. Okay, so we have our IG, which is equal to I line equal to I load. So they are all connected in series, and we just simply apply Kirchhoff voltage law. Okay, and then the current line in the system is given by I line equal to V over Z line plus Z load. So we do have over here V. Okay, here is V. Okay, if you apply KVL, so we have V over here. So we have voltage drop at the transmission line or the Z line or the line impedance over here. So we have R line. What is the formula or the relationship? We have IL multiplied by ZL. L means line. So we do have the second voltage drop over here, which is happen at Z load. So we have I load. Okay, let's say we call it LO. So plus Z load. Okay. And sorry, so we do have this relationship again after we rearrange the equation and just substitute the value of the provided in the question. So we have Z line here from question, here also from question. So now we have 480 over 4.18 plus GT 3.2 for giving the final I line is actually 90.8 angle of negative 37.8 degree ampere. Okay. So therefore, for the load voltage is, since we have just obtained the value of a line, so just again back to your sorry, back to your diagram over here. So we do have that I line equal to I load. From here, you are able to calculate the V load. All right, so the V load equal to I line Z load. Okay, and then yes, this is equal to I load. Okay, so we have defined earlier up here. Okay, so multiplied by Z load. Again, substitute the value. This is you just calculate up here again, and then this is from question here. Okay, and then finally giving us Z load equal to 54 negative 0.98 volt. And what about the line losses? The question asked in example 1. So I line square R line. So this is the remember the losses of the line. Since it happens or occur at the transmission line, you just need to pick or take the value of R, the resistance from transmission lines. What is the value? It is actually here. Okay. Alright, so just take value of 0.18. 0.1 is actually here. This one, sorry. Okay. And then now, as we move on to second question, where we have the transformer. So figure 1b shows the power system with the transformer. So to analyze this system, it is necessary to convert it to a level voltage. So this is done in 2 steps. So this is what I have explained earlier in the subchapter of Thevenin equivalence of the transformer, where we have the first step is to eliminate transformer T2 by referring the load over the transmission lines. For we will terminate here. Okay, sorry, we will try to eliminate here and transfer everything in the load crossing over to line. Okay, so this is what it means by referring load over to the transmission line. So we try to bring the Z load crossing over T2 and eliminate at the same time eliminate T2 and see what happened to the new Z line as well as the Z load. So eliminate transformer. So this is the second step. Eliminate transformer T1 now after we done with the first equivalent circuit, and then for the first process, now the whole thing is being transferred again to crossing over T1 to the supply side or the supply zone, and eliminating T1 at the same time. So eliminate T1 transformer by referring the transmission lines element and the equivalent load at the transmission lines voltage over the over to the source side. Okay, the supply side or the source side. So the value of load impedance when reflected to transmission system voltage is, so this is what we have discussed earlier. So we have the new Z load, which is Z prime load. So Z prime load is the new one equal to A squared Z load. And then what's the value of A? So this is nothing but NP over NS, and this is given as 10 to 1. Okay, so this is actually given from a question. We can get this from question. So A 10 to 1 Z load is from question again. So giving us Z prime load is 400 ohm plus J 300 ohm. So the total impedance at the transmission line level is now ZEQ, since we have here. Alright, so now we have the new Z line. So let's say we focus on the transmission line. So I have the dotted line over here, and then this is Z line. Okay, so we have the second, let's me draw it as a box. Okay, and then we have the new coming Z, which is just crossing over the transmission, transformer 2. We call it as Z load prime, the new one. Okay, here. So we have seen that this line plus this line giving us a new Z, which is, or namely ZEQ. So the total impedance at the transmission line level is now ZEQ plus. equal to Z line plus Z prime load. So Z line plus Z line Z line plus Z load is given by 400.18 plus J 300.24, because this is actually value of Z line. It's very small. Okay, just add with 410. So the equivalent circuit is shown in figure 1C. The total impedance at the transformer line level, Z line plus Z prime load, is now reflected across T1. So before we move on, we continue with this following analysis. So let's see how it looks like. So I mean the new equivalent circuit. So system with the load referred to transmission line voltage level. So now the equivalent circuit over here. So this is the Z load prime. Okay, the Z load prime, and then this is the Z load, the existing Z load. So the new Z load meaning Z load prime. Okay, so prime means this is a new Z load. Okay. So this is actually similar to what I have drawn over here. Okay, don't get confused. This is similar. Before the dotted line. Okay, here, before this one. Dotted line in my drawing is actually before the transformer 1. Okay, this is T1. So it's the same thing actually. So now let us continue with the following example or the following analysis. Now we try to level the voltage or the transmission line with the new ZEQ reflected across T1 to the source voltage level. So again, so we have the Z prime EQ, where previously we have the ZEQ. Now we have Z prime EQ equal to Z square EQ, ZEQ. Yeah. Okay. So sorry. Okay, close bracket. So we have Z line plus Z prime load. So if we expand the equation, we have ZEQ equal to Z line plus Z prime load. So again, substitute the value of Z line as well as the Z prime load. Okay, actually we can simply find from here. Okay, the same thing actually, okay? Or the same value here into here. Okay, this one, and divide everything by 10, giving us the new value of ZEQ prime is 5.003, 36.8 ohm. So notice that Z prime double load plus equal to 4 plus J 3 ohm. Which one is this one? This is here. Okay, this is located over here. This is 4 ohm plus J 3 ohm. This is nothing but Z double prime load. Okay, so you have referred the Z load 2 times. Okay, remember the first one here, transformer. All right, so we have the second transformer where you transfer the Z load ZL here. Okay, you transfer over T2, and now here being eliminated. So now we have Z L mean load prime. Okay, this is your Z line. Okay, it become together in series. So what happened? You still have T1, isn't it? So now in this process, the whole process, so these two, this is this line, sorry, don't confuse the Z line, Z load. So it's being transferred crossing T1 over here. Okay, so now Z line over here become Z line prime. Okay, so what about Z prime load? Over here, it become Z load double prime. Okay, here, Z load double prime and Z line prime. Here, and this is here. And the resulting equivalent circuit is shown in figure 1D. The generator's circuit is simply like here. Okay, so now we have been eliminating both transformer 2 initially and transformer 1. So it's nothing, it's gone over here. So we have the Z double load and Z line, Z prime double prime load and Z prime prime load line. Okay, and then here again apply. KVL, and you will directly calculate the IG, the generator's current. So 480 over 65003 is from here actually. Okay, ZEQ prime into here. Okay. Or you just here you just add up over here these two. Okay, Z line prime plus Z double prime load. So giving the value of IG 95.98. Sorry, 95.94, blah blah blah. Okay, now we try to work back, or we try to re-expand our circuit. So knowing the current IG, we can now work back and find I line and I load. So working back through T1, we get NP1 IG equal to NS1 IG. So this is from the turn ratio. This is where the turn ratio play a crucial role. So we have this relationship where A equal to NP over NS, or we can simply say NP1. So for the transformer number 1. Okay, so this is equal to, I S IP. So in this particular example, IS is really I line. Okay, and the primary part is actually IG. It's coming from the generator. Okay, and then you just need to rearrange. Okay, so we have cross multiplication, for example, so giving us that IG and P1 equal to I line and S1. So this go here. Okay, rearrange in terms of I line. So we have the turn ratio is actually 1 over 10. So we have IG, we just obtain or just calculate here. Alright, so into here and giving I line, okay, equal to 9.594, blah 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 blah. Okay, working back through T2 give. So similarly, we have back to your basic relationship of turn ratio. We have the NP2 at the transformer number 2. Alright, so we have NS2. So this is equal to I line. Sorry, it's not I line, but it's actually I load. Alright, I load over I line. Okay. Okay. Now just need to rearrange into this relationship where we have NP2 I line. Okay, equal to NS2 I load. Okay, and here we go. So I load equal to NP2 over NS2 I line. So the turn ratio 10 to 1. So the I line again, this is from here. Okay, you just calculate over here, up here, and giving the I load 95.94 negative 36.88 degree ampere. So it is now possible to answer the question originally asked. So the load voltage is given by V load equal to I load Z load. So this is again in the question. It's directly provided in question, and I load is just obtained and giving us the final answer of V load. Okay. Same goes for the line losses this time around. So try to calculate using this relationship or this equation. So happen at R line, which is 0.18. Okay, this is the actual value of R line provided in question. So R line square 9.9594 ampere square multiplied by 0.18 ohms, giving us the new line losses after we put in the transformer. The value is now 16.7 watt. So this is end of example 1. Thank you very much for watching. Hopefully hopefully we will continue in the next video, and have a nice day ahead. Bye bye.